each of these different forms are representing the same function, but there's pros and cons to each form. And each of these four things, you should be able to easily identify from one of these expressions without needing to graph it. So, table 6, what is the vertex? Okay, so anytime we're talking about vertex, we're talking about a coordinate. So it should be two numbers. Try again. Or can you tell me from what expression would it be easiest to see the vertex from? Okay, that's our factor form. In factor form, it's actually easier to see what class? The zeros, which is another word for x-intercepts. So this one won't easily tell me the vertex. Table 7, which one of these others would tell me the vertex pretty easily? The third one, because it's in vertex form. And in vertex form, you can easily identify the vertex. I know we haven't talked about vertex form this unit, but today we are. Because vertex is a feature of the graph, right? Like we don't really do a whole lot in the solving, except for that you might be given a problem in vertex form and asked to convert it to standard form or something like that. So unit 6 was mostly about the graphing. This unit's mostly about the solving in other ways. What of our vertex formula is the vertex? Like what letters? H and K. H and K. So now knowing that, hopefully jogging our memory. Table 8, can you tell me what the vertex is? What number is in the H position? Okay. So the vertex is actually going to be -3, -1. Because if you remember, like, because it's x minus whatever number you're plugging in, it'll look opposite. So if I plugged in a negative like this, x minus a -3, that is what makes it look like a plus because of that double negative. The K always matches the sign. H is always like opposite of how it looks. So my vertex is -3, -1. Question on that? Okay. So then table 9, what about my x-intercepts? What are they? We mentioned that they're easiest to see from factor form, so. Close. Think of like the other definitions or things we call x-intercepts. The x-intercept is whenever this is 0. You guys finish that? X-intercepts are whenever blank is 0. Not x. Okay, good. So your x-intercept is whenever y is 0. Y would be like your output, right? And then you're thinking, what does x have to be to make this parentheses 0? What does x have to be to make that parentheses 0? That's your zero product property. So table 9, you want to try that again? What does x have to be to make it 0 on this side? Okay, good. And then the other x-intercept that makes this side 0 would be, okay, perfect. So I know we've done that before, but it's been a while. That you still need to know how to do. So x-intercepts, if it's really simple factor form like this, always have like opposite symbols and how it looks here. All right, table 1, what about the y-intercept? So I can't easily see my y-intercept from the first equation. What is it? Good. So when it's in standard form, you can see the y-intercept super clearly because it's always your constant. Think like when we did projectile motion, like that was always our starting height, like, and your starting place is usually your y-intercept. So my y-intercept is 8. And by definition, y-intercept is whenever x is 0. So yeah, if I plug in 0 here, I only have an 8 for the y. All right, the last one, line of symmetry, that one, or it was challenging, I guess, like more people tending to get it wrong, but then there were easier ways of doing it. There is an equation for it, but I don't know that anyone remembers it. Was anyone able to figure out what the line of symmetry was without graphing? Or like when it came up on your last unit test, I showed you the formula. I showed you that the formula was this, x equals negative b over 2a. But then I also told you that it is always this. If it's going right down the middle of your U-shaped graph, what else goes right down the middle of your U-shaped graph? Not necessarily. Something else. The vertex also goes right down the middle. So the other way that I explained it to you was that your line of symmetry is always x equals the x of your vertex. So in vertex form, where you can clearly see the vertex, my line of symmetry is just the x equals the x of my vertex, which we said was -3. That's like probably the simpler way of thinking of it. Line of symmetry is x equals the x of your vertex. But this is how you actually calculate it. So when it's in standard form, that's where you can figure out what to plug in for b and a. So my b value is what? Not 8. 8 is my c value. Okay, 6 is my b value. Over 2 times a, what's my a value? Should be the number in front. So what is it if it's not written? Good. So 2 times 1 on the bottom, so this is me plugging it into that. When you simplify, you get -6 over 2 times 1, which is 2. And -6 divided by 2 is -3. Which I did show you how to do in the last unit, but then I also condensed it to, it's the x of the vertex. Questions on that? Okay, so really good warm up. This lesson is super important. It's lesson 22 and 23 combined, which you might be wondering, like, what happened to everything from like 16 to 21. We rearranged this unit so that this was moved up, so that when we do quadratic formula tomorrow, it's not confusing, or at least maybe not as confusing. These are all important features of the graph, and today we're mostly focusing on how to do it without graph. And also like rewriting expressions in vertex form back into standard form and things like that. So by the end of the lesson, you should be able to identify all these different things, which most of them we already did in the warm-up without graphing, and then be able to convert standard to vertex, vertex back to standard, and all of that stuff for rewriting. I'm recording right now, so if you're ever absent, if you ever want to refresh your memory on what we've already learned, check the slides. Puzzle piece is this one, 22-23 practice. And no more like small quizzes. All we have are these big assessments. We're testing for Unit 7 next week. And like I mentioned before, you should probably retake your Unit 6 test if that's not good. Last semester, we had 5 unit tests. So if you did bad on one of them, probably wasn't as big of a deal as if you do bad on one of your unit tests this semester. So we only have 3 this semester, and one of them is next week. So I have had students that are failing ask me, like, do you think I can even pass? Like, is there still even a chance? Yes, absolutely. Retake or correct your Unit 6 test, which we talk about those concepts almost every day. And then you still have a test coming up, like, do well on that one. That's 2/3 of your assessment grade right there. So, highly recommend do what you need to do other than cheating this one, so that you're ready for this unit test next week. But moving on. We'll have maybe 1 or 2 lessons left after this. So another little bit of review, and again, I want you to do this without graphing. For each row, you have the equation in vertex form. You should be able to tell me the vertex without me giving it to you, but here it is. Okay. Anyway, so equation here, coordinates of the vertex. You need to tell me if it's a maximum or minimum. And then bonus, if you remember what maximum or minimum specifically is, then you can write it here. But in about 3 minutes, I'm going to start asking you, is this a maximum or minimum, and how do you know? No graphing. Okay, 3 minutes starting now. X, does it have a maximum or minimum? And how do you know? Okay, so the coordinates of the vertex don't actually tell you if it's a maximum or minimum unless you know like the other coordinates involved, like maybe you have a table, which you'll see in like a later example. It's the equation that should be able to tell you. Do you know what part of the equation should be able to tell you? When the A is negative. All right, so the A in vertex form and the A in standard form is always in front of the x squared, right? So if the x squared looks negative, or the number in front of the x squared is negative, then it opens down like a frown. When negative things happen to you, you frown. So when the A is negative, it opens down, making the vertex my highest point of the graph, so we call it a maximum. Additionally, because this will pop up on your test, I want to kind of add to this now. When we talk about maximum, we're really just talking about the y value of your vertex. So if it said, what's the maximum of this equation? I'd say 6 is my maximum, not like the whole vertex. So think about it when we did the word problems. The y-axis was usually height. The x was usually time. Time like just continues to increase, right? But on the y value is where you can see like, again, your maximum height or your maximum profit or whatever it is. So really, we're just referring to the y of your vertex when we talk about minimum. Questions on that? So now like add that in when I ask you. Table 3, is g of x a minimum or maximum? It is a minimum. What is the giveaway? Because the A is positive. Good. So when it's positive, it opens up like a smile, making that vertex my lowest point. And then also class, what is my minimum exactly? All right, hello, next question. What's my minimum? This is the information I have, and we just talked about it. -3. Questions on that? The y of your vertex. The x of your vertex tells you line of symmetry. The y of your vertex is your minimum amount. Table 4. Is h of x having a maximum or minimum? Minimum. Because again, the A is positive. Class, what is my minimum for this one? 7. So even though the x is negative, like it has nothing to do with that. The y of your vertex is your minimum. Table 5, does k of x have a maximum or minimum? No. Minimum. Because again, the A is positive, the x squared is positive. What is my minimum? Good. And table 6, m of x, maximum or minimum? Because of y? Because the negative x squared, the negative A. And class, what is my maximum? So the test question will probably say something to the effect of, does f of x or m of x have a higher maximum? And maybe they'll just give you the vertex. You would say m of x has a higher maximum. They'll say between g of x and k of x, which one has a higher minimum? You say g of x, because that would be higher than the -12, and things like that. All right, so good, moving on. Any questions going before we do that? Now, going from one form to the other, let's talk about going from vertex to standard form first, which is what you see here. Standard form basically means that it is fully simplified, right? It's the ax squared plus bx plus c. Like there's no multiplication you can do. If there is any you could do, then it's not in standard form. So for vertex form, going to standard form, all you really have to do is multiply and simplify. Remember that, because I'll show you this one and then you'll try this one. Remember that you can't apply the power rule, like you can't just distribute the exponent if there's addition or subtraction in the parentheses. It doesn't work that way. You would have to expand this first. So it has a perfect square in it. First, you would expand it. This also had a +1. You would multiply this out with FOIL, double distribute, whatever you like better. When I FOIL it, so I'll do it right now. X times x is x squared. Outer term, x times 5 is 5x. Inner terms, I get 5x. Last terms, I get 25. We also have this +1 there, so it'll be there. And usually after distributing, you have to do what? Combine like terms. X squared does not have a like term. 5x plus 5x is what? Just 10x. So when you combine like terms, you just combine the numbers in front and keep the variable the same. So 5x plus 5x is 10x. And then you can always combine the single numbers. So 25 with 1 is, and that's standard key. So I like converting to standard form because all you have to do is basically multiply. Which we didn't do. So you try part B now. And then once we go over that answer, I'll show you how now to go from standard to vertex. But we try part B similar to this. Okay, really quick. What's the first step in part B? What do I need to do first before I can do anything else? Expand this parentheses. It's written as a perfect square. We want it in the longer form so that we can multiply it. So that would be next. When you FOIL it, table 4, what do you get after FOILing? Okay, good. So this is from FOILing this part. The outer and inner, it becomes negative 3x minus 3x, which is negative 6x. And then this minus 7 is still there. Simplify. Our final answer ends up being x squared minus 6x plus what? 2. Questions on, yes. We'll add you to the line, you'll be after China. I don't know that there will be more time, but everyone knows from this stuff. Okay, the questions on this. Now, this one, like the curriculum wants me to have you now try it by completing the square, put it back into vertex form because we have a perfect square in it. I'm going to show you the way that would be easier since on your test you already have to identify things like line of symmetry and vertex without graphing. So I'm going to show you a slightly different way. So kind of ignore these instructions. We're not really doing anything with number 2. When we are trying to go now from standard to vertex form. So vertex form, let me remind you, looks like this. All right, the A is the same as the A in standard form. So like my A is just going to be 1. I need to figure out what my vertex is so that I can plug it into this formula and have it in vertex form. Luckily, we know that the vertex is right in the middle of your U shape. So is the line of symmetry. So I think it's much easier to use line of symmetry, which is this formula. Since we know the line of symmetry is always the x of your vertex. So my line of symmetry formula is x equals negative b over 2a. The line of symmetry is the x of the vertex. And you can see your A, B, and C from standard form. So I only need B and A though for this. Tomorrow he'll do C, but what's my B value? That's my C value. So 10. And let me put this on top of it so that we know what I mean by A, B, and C. Yeah, I could probably get this too. But we're plugging it into this formula. So negative B, plugging in B is 10. Always use parentheses. And what's my A value? 1. Simplify, it's negative 10 over 2 times 1, which is 2. Negative 10 divided by 2 is negative 5. That is the x of my vertex. So when I'm plugging this in, so here's my formula, I'll put it to where all I have to do is plug in my numbers for h and k. The x of my vertex is negative 5. I'll clean up these symbols later, like the double negative, but plugging in a -5. To find the y of my vertex, since this is basically like an input, this is an input, all I have to do to find the y is plug it in and then get my output. So this was my given equation. If I want the y, I need to plug in the x that I just found. So I have -5 squared plus 10 times -5 plus 9. And please, for the love, use a calculator. Really only have to type in that part into your calculator, and again, you use the parentheses. If you don't put these parentheses right here around this -5, it will mark it wrong, or it will give you the wrong answer. So anyway, we're plugging it into our equation to find now the y of our vertex. Was 10 times -5 plus 9. All right, we get that the y of our vertex is -60. So then we get y equals -16. That would go here in my vertex form. Questions on that? So then I'm just gonna clean up these like redundant symbols. What happens when you have a double negative? So in my final answer, it will be x plus 5 in parentheses squared. And normally we don't write plus a negative. Normally we just write minus whatever. This is my final answer from standard to vertex. Find your line of symmetry, since that's the x of your vertex. Like in your x, and solve for your y. To me, that's way easier than the other way. Questions, comments, concerns? We're in our last like home stretch. You might even have time to do your practice, but good so far. These next two questions that are kind of similar to the warm-up, where you're identifying vertex, x and y intercepts, and line of symmetry. You are supposed to try them without graphing. Of course, if you have graphing on your test, you can always check your answer, but these are really great test questions. So you have one that is an equation, and the other one's a table. So be able to identify all these different things without graphing. I'll give you 5 minutes and then I'll check in, see how you're doing. But try the next two. I'm not gonna scroll down, I'm gonna leave it on this in case people want to look at it. But give me 5 minutes to try the next two. So we are given an equation and asked about all these different things. Now, keep in mind on your test, what's more likely to happen is that they're not just going to ask you to identify these things. They're going to say between f of x and g of x, which one has a greater y-intercept? Between these two functions, which one has a higher vertex, like things like that. So you have to be able to identify them in order to be able to compare them. Table 7. What is my y-intercept? Is in 0. That is correct. Since it's in standard form, that's super easy. It's just a constant. My y-intercept is really easy to see when it's in the standard form, no calculations necessary. But by definition, y-intercept is when x is 0. So if you did plug in a 0 for the x, all you'd be left with is -36. Now, x-intercepts, by definition, are when what happens? Close. That's y-intercept when the x is 0. So when it's the x-intercept, the y is 0. All right, and f of x is kind of like y, is our output. So if I make this 0 and I start solving for x, it's really easy to see my zeros when this is in factor form. So that's what I'm gonna do. We might have done it another way, but I'm not supposed to do it with graphing, so factoring would be the easiest to see my x-intercepts. Whenever you are solving by factoring, you need to look for a GCF first. Is there a GCF between 3, 24, and 36? Is there a number that divides evenly into all of them? So 3 is my GCF. 3 does divide evenly into the others. Always see if your smaller numbers can be a GCF. There's no rule that you have to factor out like the negative version or the positive version. But I know that factoring is a lot easier when A is 1. So I'm going to factor out a -3 for the GCF. And factoring is a lot easier when A is 1. So I'm going to do this so that my A becomes a 1. All right, so divide each term by your GCF. I get x squared. What's 24x divided by -3? -8x. What's -36 divided by -3? Definitely becomes a positive. Okay, so that's me looking for a GCF first to continue factoring. We have to see if the parentheses can be factored. So that's a trinomial, like diamond method. Looking for two numbers that multiply to 12 but add to -8. What are they? How can I multiply to 12 but add to -8? So if you don't know, then go down the list of numbers, but I feel like it's not that you don't know or that you can't figure it out, it's just that you don't want to. Faster we get through this, faster we can get. So I'm looking for two numbers that multiply to 12 that add to -8. So 4 times 3, there is no way I could add them to get a -8. So it'll have to be something else then that multiplies to 12. -2 and -6. Because it multiplies to a positive, adds to a negative. This is what makes it work. So then my factors look like this: x -2, x -6. And if I'm trying to figure out what each x has to be to make it 0, then my x-intercepts are having to be 2 and 6. Right, so 2 minus 2 is 0, 6 minus 6 would be 0. It's always like opposite of this. Now, coordinates of the vertex. They didn't give it to me in vertex form. I have to find line of symmetry anyway. So the way that I would go about it for this one is just do my line of symmetry form. And I would do the line of symmetry first and then I find it. And you do it based off of the original, not like any factors off the original. So what is my B value? So I'm plugging that in for B. What is my A value? So plugging that in for A. And simplifying. So I have negative 24 over 2 times negative 3 is negative 6. That's negative 24 divided by negative 6. So my line of symmetry is x equals 4. And that's also the x of my vertex. Now I just need the y of my vertex. So then to find my y of my vertex, all I have to do is plug into my given equation my x and solve for y. Again, you can and should use a calculator. Only a computer after that. But I would, for work shown, like to see that part. And then the y value you get from putting it in your calculator. Anyone have the y of the vertex already? Okay, that does sound correct. Right, but that part you get from putting it in the calculator. So -3 parentheses 4 squared plus 4 times 4 minus 36. Okay, good, any questions? All right. Last one, and it's the first table that we're seeing on this unit, but I think tables are even easier than equations. So going to the last one. We need to identify all these different things, but now from a table. So y-intercepts. By definition, your y-intercept is when what happens? When x is 0. So look at your table at your x's. They do give me an x value of 0. That's my y-intercept. Easy. So whenever x is 0, that's your y-intercept. So my y-intercept is 0, 5. X-intercepts are the opposite. What's 0 for x-intercepts? Not the x. When y is 0. So check your outputs or your y values. Here I have a 0 showing. Here I have a 0 showing. I should never have more than 2 for at least quadratics. And my x-intercepts from this table are -2 and 2. All right, vertex is so easy to identify. You just might not have ever had to done it from a table before. How do you identify vertex when you look at a graph, for example? It's always the turning point. So if you remember that, then you should be able to identify the turning point from a table. Because quadratics don't just go consistently up or down, they do both. So the x's won't help you because the x's are independent, like time, like it just goes on increasing. But in the y values, you can check for like when it's increasing to where it stops. And then goes the other direction. So based on that, what's going to be my vertex? So as a coordinate, 0, 5. Because surrounding the 5, it like starts to mirror each other, right? Like it's 2s, then 0s, and then it kind of click off. But it increases up to that point, and then it decreases. So that's my turning point. Line of symmetry, I don't have an equation to plug into my formula, so you have to remember that other definition for line of symmetry. Line of symmetry is always the x of your. So what's gonna be my line of symmetry for this one? Gonna be x equals 0. You need to have the x equals, or technically it's not one. But it's always the x of 0. What is my maximum? 5, good. Always the y is the vertex, and it is the maximum, so we have the highest y. All right, so lots of things covered today that are on your test, so hopefully, you know, all the definitions are now making a bit more sense. You do have even some time, way more than my first hour had, all the way to the end. But it was a really important lesson, so